Hello, and in this video we're going to go over the March 19 paper 2 version 2. Okay, so usually in section B, which is the part that isn't dependent on the pre-release material, it starts with a pseudocode question where you have to find some logical errors. So in this case we've got to input 50 numbers and only the positive numbers are stored. So count equals 1, total equals count, repeat until less than 50. Input 50 numbers, okay, and only the positive, okay. So count equals 1, total equals count, repeat until less than 50. So there's probably an issue there, there's an issue here. Input the number, if the number is not 0, then total equals total plus count, and if count equals count plus 1. Okay, so there's quite a few errors that we can pick up there. The first one is that total equals count should be total equals 0, because if we'll start that at 1, that means we've already got one number where we don't at the moment. Number is not equal to 0 should be number is greater than 0. It's a positive number. Not equal to 0 would allow us to also include negative numbers. Here where it says total equals total plus count, would add 1, 2, 3, however many times we've gone around the loop here, where we want to add the number that we've just input, if that number was greater than 0. And the last one, less than 50, okay, so 1 is less than 50, so it can end. What we need to think about is making it greater than 50, or we could say until it's greater than or equal to 51, or we can say equal to 51, and that would mean that we've reached 50 and we've gone one more time, which means we're now greater than 50. Show how you would change the corrected algorithm to only total numbers greater than 0 and less than 20. So we need to think about what we're going to do on this line. So if number is greater than 0 and number is less than 20, in the mark scheme you get 1 mark for this part here, 1 mark for this part, and 1 mark for the AND. I've tried to make it a slightly different shade of red so you could see. Now we're going to move on to this flowchart question. It's a relatively simple flowchart question where we've initialized these values at 0, and then we're going to input a type, and if it meets these conditions, either these are going to be added to the variables as a counter. If it's Z, it means we end the program. If it's not S, A, C, or Z, then essentially it ignores it and then loops through the program, acting as a type of validation. Now I get to the table here, and you're going to be asked to put these inputs into the system and then go through and write out what happens. So you can see I've got 0, 0, 0 here, which is this stage, and then we're going to get to the point where the next line where I can input the first type. So here I'm doing S, and that's adding 1, S, 2, S, 3. A adds 1 to adult, C adds 1 to child, so you can see these are being added up. A is now going back to adding up to the adult again. W is not an accepted value, so nothing happens, it just gets ignored. SS adds to senior, D is not an accepted value, so nothing happens here after it's been input. C adds 4 here, and then Z activates the output of senior, adult, and child. Now we go on to a pseudocode question where we need to identify if these are selection and repetition. So this is a for loop, so that's going to be repetition. This is a while loop, so it's going to be repetition. This is an if statement, which is a decision, so it means some selection has been made if I should do this or something else. And this one is repeat until, which is a repeat until loop, one that we don't use in Python, but we need to be aware of. Essentially this is a pre-condition loop, this is a post-condition loop. And again, that would be repetition. Now we're getting some questioning about some programming skills that will usually ask you about validation and verification in this section if they haven't already done that in part A of paper 2. So a programmer restricts the values to less than 90 and greater than 60. Is that validation or verification? It's validation. Validation means where we set up a series of rules. Verification means where we manually have to check if it's correct. So I can validate to say you can only input strings and they can only be a certain length, but if that was somebody's name, but I would have to verify the name manually to check that it had been spelt correctly, usually against another record. Name the check that needs to be used. This would be a range check. If we're checking in between certain values, it'd be a range check. Now we're going to be asked ways that we can check, or what tests we would carry out to make sure this section of the program was working correctly. So the first one we should always do is normal data. So the range is between 90 and 60, so I'm going to input 65, and I'm going to show that the program accepts values within the range. The next one I'm going to do is erroneous. I'm going to type in a number, but I'm going to type it in as text, 70. And this should show that the program rejects this value. So it should reject anything that isn't an integer value between these numbers. And then I'm going to the last one I'm going to do is some extreme data. So I'm going to type in 89 because I'm testing the very, very top end of the validation. You should always test maybe 59, 61, 89, 91 to check that you've set up the greater than and less thans or equal tos correctly in your if statement. So you should always check one short of the number that you're checking against and one beyond to make sure it's working within the range. Our last question in this paper is a database question. This one's again a very simple database question. We have some tire codes, so these would be our primary key, our unique values for each field. Width, diameter, if it's a tube tire, what terrain, and how much we have in stock. Here's a query by example grid. They've already completed one for you. Again, I think there's something gone wrong when I've converted it, but these should be ticks to show that these are appearing. I think it's converted the tick to an ASCII character. And here we're finding bikes that are 28 width, and their terrain would be mixed. So out of here, I would probably return one. Sorry, it's got to be both, hasn't it? So here, mixed. So 1, 2. You asked to fill out this section. So to show tire code and stock level. So again, I've done the ticks properly in my example, but tick, tick. And ascending order of stock level. And 24 millimeters and asphalt. So we can use this as a pretty good example. So the first thing I need to do is tire code from the bike tires table, and I want to show them. Then I want the stock level from bike tires, and I want this to be in ascending order, so the smallest number to the largest number. The width instead of 28 is going to be 24, and I don't want this to show because I only want to show these two fields. And then terrain is from the bike tires table, and instead of mix this time it's going to be asphalt. Okay, this is the last question in this paper, a relatively simple question, second half of this paper, but there's the main things to be aware of is just practicing these query by examples and making sure you know about the show and about the ascending and descending. And please make sure here you write the table name each time.